All right, so I've got the same rough agenda, slightly different order. What stumbling blocks have folks run into? Fortunately, no one ran into that same bug that I ran into.
I got a little confused when categorical versus continuous attributes were talked about, and when to use each instance of each and how it impacts the training of the layers. Did did anybody else have any confusion over that, or did it make sense? It seemed to be glossed over or explained very quickly around the 28-minute mark, I think, and spent maybe a minute, 2 minutes describing it, and it just felt that there wasn't a lot of intuition behind it. At least that was my feeling. But
you mean embeddings?
no, it was in the area of using attributes as categorical instead of continuous. So if it's continuous, the deep learning model will need to generate a smoothing function, whereas if it's categorical, each attribute can be treated differently. So I didn't get a good sense of what the intuition is there behind that for training the models. So the overarching theme of that, I think, is to use categorical if possible.
Yeah, that's what I got out of it. I think the way I interpreted it was that, with deep learning in general, what the network is going to try to do is to fit a function that maps your inputs to, or patterns in your inputs to your output. And if you're with the continuous variables, it's going to treat those as, treat those in that way and kind of try to map a function. At least that's the way it kind of made sense to me. But with the categorical variables, is not quite trying to map a mathematical relationship between, different points on different points within the categories. It's not treating those as like a mathematical relationship that is mapping to the output. I'm not explaining it very well, but
what I understood is that this embeddings for categorical variables is that you try to represent each instance of those category with a higher dimensional mathematical representation as a vector. And then you can cover things like, okay, Saturday is closer to Sunday, for example. And I think Jeremy said that those vectors have a meaning. So when you look at them, you can see distances, for example. It's the same thing like for words. When you have, for example, male and female and king and queen, they tend to have the same relation between those vectors. So it's really just creating a representation that can take all those information in. That's at least what I understood.
Yeah, I think Adrian's question is why, for example, like when you could use year as a continuous variable, or some other variable that could either be represented as continuous or not, why does Jeremy suggest using it as a categorical variable instead?
Okay.
Yeah, so the only intuition that I could gain from that is that the space of possible solutions is reduced if you use it as a categorical, because it's boxed. So what we can learn on is within a set of possible attributes, whereas if it's continuous, then the space is much larger. But that's not. I don't think that's an adequate explanation, but that's some intuition that I was gaining from that. But
yeah, but I think this weekday thing is a good. You can get a good intuition for this too, because when you say 1, 2, 3, 4, 5, 6, 7 for each day is a continuous variable, then you have really just the numbers and the relation between 1, 2, 3, 4, 5, 6, 7. But when you encode, for example, Saturday with a higher dimensional representation, then you can have all those things that I mean, on Saturdays, people are more often go to shops, for example, and stuff like this. So you can get more information into this variable. That's, I think Jeremy said something like this.
So I think, Kai, what you're saying is that the reason to opt for the categorical ones is because this embedding allows you to kind of stuff more information or get more information into the relationships than you would with a continuous. And so that's one factor. And the other factor, I think, is the one that you're referencing, Adrian, and that is and I guess they're kind of, it's almost the opposite. With continuous variables, the network is looking for a relationship between points on that continuous space that might not be relevant or might not exist.
So my intuition was a little bit different. I can have a go. So my intuition is that categoricals are essentially clusters. So when we look at a dog versus a cat, there's actually many factors that determine its. Sorry, somebody's very noisy in the background. The factors that go into determining whether it's a cat or a dog are many and varied, and we're essentially just summing up and then essentially using all these different vectors to make an assessment about whether it's a cat or a dog. So the way I think about embeddings is it's all the various different factors that go into making that choice in situ. So, you know, the geography, the days of the week, these kinds of, I'm not really adding to the intuition of the weekdays, but my understanding of why you decompose categoricals into embeddings is that there are many factors that go into defining when something is in a category or not, and the embeddings are essentially giving the machine learning algorithm the same capabilities as we have, which is to break that down into a whole bunch of different factors.
I think, you know what, with going back to the year, why not use year as continuous versus this discrete variable? I think if you do it as discrete, you might extract some more features out of it, such as like every, you know, the turn of the decade, the year 2010, 2020, 2030, those might be kind of more important. So the embedded vectors might be able to capture that, or turn of the century or turn of the millennium. Also groups of years, just like every fourth year there's an election. So, you know, around those years, there might be more activity. So hopefully your embedded vectors might be able to capture some of that. I think that's just another motivation for using the embeddings.
Okay, is it related then to the fact that with categorical, there's some repeating there, so there's patterns that can be extracted via the embeddings with categorical, whereas with continuous, it's yeah, as the name suggests, it's just continuous data. There's no you can't discover a pattern within the data we're trying to learn on.
I think you're right.
I think that's the intuition. I'm not sure if I agree with it. I actually think that it might prove useful to create embeddings for continuous variables, but I just don't know what it would mean when you sum them all up, because it doesn't make any sense in that sense. So there's no reason why a continuous variable can't have many factors contributing to it, but it's just not obvious how you would turn those, how those different factors would contribute to a single value. It's quite vague.
I think part of the issue there is a computational one, and also the fact that continuous variables, you'd have to either bin them or identify some arbitrary precision and do your embeddings at that resolution. Otherwise, I think Jeremy mentioned that if you have even a categorical variable that has like a cardinality of, you know, several 100,000, you wouldn't want to use embeddings because it just, the complexity becomes too much.
Fair comment.
Any other thoughts on this topic?
I was still kind of, you know, once you get the category, the embeddings down, okay, but like, how do you mesh that with the other variables, the continuous and so forth? Like, is there, you know, is there a next layer in the neural network where each neuron gets all the feeds from the embedding and it gets the feed from the continuous? You know, I'd like to see that in for like a layer diagram, a neural network layer diagram. Does anybody know how the next layer up from the category and continuous feed into it?
What I understood is that it's the same when you would do one-hot encoding. So it's computationally much more efficient, but basically the same. So when you do one-hot encoding, it's basically a big multi-layer perception network. And so it's basically the same, I think.
So the next layer would be like a fully connected layer that's connected to all the categories and all the continuous variables. Each neuron is connected to everything.
Yeah, that's what I understood.
Okay, thank you.
Interesting. So when you said perceptron, you were talking about an SVM, right? A linear SVM?
No, multi-layer perception is just the classic dense, fully connected network.
Okay.
The same thing you would attach to the end of an image classifier, for example.
Mm-hmm.
But the embeddings happens early in the network. Is that right? That's happening at the front end.
Yeah,
Is
I think
it?
so.
There's a lot of noise from someone, I don't know who. So I didn't actually get any intuitions around this. So let's, if you wouldn't mind, can we dig a little bit deeper into this? So I understood that the idea of decomposing the categoricals into the embeddings, that made sense to me. But what's the intuition about at what depth that would make sense? To me, that only intuitively makes sense at the very early layers, but maybe it makes sense deeper in. I'm not sure. Does anyone have any insights to that general question?
Take it as one layer. Each of the one vector with, let's say, 5 numbers, and those 5 numbers are the weights. And then you, well, actually, does that make sense?
There's a little bit of noise at the end of your explanation, Kai. Can you? Ooh.
Is that from me? No.
No, that wasn't from you. I was saying there was some noise in the background while you were speaking. I don't know if we caught that. I think I got well, I think I just muted you.
Yeah, well, I actually don't know if that makes sense, but what I understood is that each of the numbers in this vector representation is one weight, right?
One weight, not one activation.
Yeah, one weight.
Okay, interesting.
So it's because, I mean, Jeremy said that this is initialized randomly at the beginning.
The embedding matrix.
Yes. So each vector for one category is initialized randomly, right?
I think so. Or I think there was some conversation about like pre-trained embedding matrices, like, or pre-trained embeddings, I guess you would say, like Word2Vec and some others. But I think here, he started with random.
Okay, so and then when it's trained, when this embedding matrix is trained, then you put in one instance of your data set, and then one of those vectors is activated and then pushed through the neuron. And then after that, that's the output that goes into the next layer. I don't know if that's the case, but that's what I understood.
I wonder if this article is useful for this. Did anyone take a look at this article by Rachel, where she talks about this categorical data thing? I haven't dug into this yet, but she elaborates a lot on the categorical versus continuous, I think, in here. And in the whole idea of embeddings.
Okay.
I'll put the link to that in the chat. This might be a good one to follow up on the this whole categorical piece.
Bring it up. It's interesting. Most of my learning was actually in data manipulation. I wasn't gaining many insights into the actual neural network structures themselves. What I was gaining insights into was using pandas and these other tools to essentially reformulate your data to make it compatible with the learning systems that are built into Fast.ai.
Mm-hmm.
And I'm kind of missing where you got these insights into the actual into the actual neural network side of things. I missed that completely. So it's interesting that you perceived you got all that information out of the same lectures, and I completely missed it. I'm just wondering.
No, I used neural nets before, but those classic neural networks.
Oh, I see.
Multi-layer perceptron networks.
I've looked into them. My understanding of perceptrons was that they were basically SVMs, the old version of perceptrons. I think that's wrong, so I'll have to go back and look at that again.
It's basically, it's just a neuron is just a weighted sum and any activation function you choose. And
Right.
I think that's when you have this dense connected networks, that's what's called multi-layer perceptron network.
Yes, yes. Multi-layer perceptron, I understand. It's just that singular perceptron, my understanding was it was tightly coupled to an SVM, but maybe that's wrong. I'll redo my reading on that.
Yeah, I don't remember that there was a command that you can use, and I don't know if it was in. I think it was in the Fast.ai. It comes from the Fast.ai library. You can go to your learner object, and there's some command that you can, some function you can call that'll print out the different layers or print out the network architecture.
Yeah,
that might be an interesting thing to do after, after learning a model based on these categorical variables, and see if it kind of points to where everything is coming in.
Yeah, I'm just reading something here right now, where back propagation to the sky has not been possible over discrete representations, and it is over continuous representations of vectors. I would also point to the Word2Vec learning model for learning and word vector representation. So I'm thinking in that paper, if the words were represented as discrete instead of continuous, then would you still learn word embeddings? And I'm thinking the answer to that is probably no, that those words usually represent something continuous value. But yeah, I need to do more reading on that one.
Adrian, there was some kind of muffled, some noise and muffled sound on your end. It sounded like you were you reading from that from the Rachel article?
No, it's just a question here on Stack Overflow that I'm reading, where they're talking about Word2Vec algorithm that learns word embeddings. Are you familiar with that?
I don't think I came across the Stack Overflow article.
Okay, the Word2Vec paper. Are you familiar with that one?
Mm-hmm.
So what's mentioned here, not in this paper, but in this answer, is that backpropagation is not possible over backpropagation is possible over continuous representations, but not over discrete. So perhaps there's a link there with representing data as categorical instead of continuous.
So if backprop doesn't work for discrete, how are we doing it for these categorical variables?
Yeah, that's I'm just thinking as well. So yeah, I think I need to research this a little bit more myself. I don't understand it fully. But I have gained some knowledge just based on what you guys have been saying. But how would it apply to backprop? I'm not sure. But I would have thought that the parameters of backprop need to be continuous, not discrete.
Mm-hmm.
I'm sorry, but I couldn't understand that. But Sam, can you maybe open the link that I posted in the Zoom chat? Yeah, so that's what I understood is that when you usually use this one-hot encoding scheme and have weights after that, so that's the classical way to do that. You have weights and then the next neuron. And what you do for embeddings is really just pull in the weights into this one-hot encoded scheme because it's just ones and zeros, and you can just, it's a matrix multiplication, and you can do that step before. And so it's basically the same. It's just really a fully connected layer to the next layer in the network.
Okay, so to maybe expand on that, we can imagine this hidden layer as being a network that looks like the networks that we've talked about before. So, some combination of convolutions and activations, and well, maybe not convolutions here, but
just fully connected
layers. And if we were doing one-hot encoding, this Jeremy talked about, if we were doing one-hot encoding, we would have these input vectors and apply weights and send them into our fully connected network. With the embedding, is basically we're just transforming these, you could think of it as transforming these one-hot encoded input layers with a set of embeddings that kind of give it more, that encode more meaning. Yeah.
Because those one-hot encoding schemes getting pretty big pretty soon when you have higher cardinalities of your variable, and that's a lot more efficient to do it like that. And I mean, I think Jeremy said that it's basically the same like one-hot encoding, but just computationally much more efficient.
Mm-hmm.
Going back to that backprop and discrete, I think backpropagation does work with discrete inputs. So just like you know, you use it like back propagation through time for language models, but you know that backprop works with discrete.
Yeah, it does.
Yeah, I think Adrian thought it may not.
I couldn't understand it, sorry.
Adrian, what were you reading there?
Yeah, so that was just a Stack Overflow question that I was reading out loud. So, so just on that, the reason that I was thinking it may not work is because if it's a discrete variable, can we modify it in a way? So with discrete, it needs to a discrete. Does this discrete value have to represent a meaningful association with what it's describing? And by that I mean with backprop, we're modifying values in order to learn our model. But if it's discrete, is it still discrete when we change it? When we're applying the minuscule changes as a result of taking the partial derivatives, is it still a discrete variable? That's really what I'm thinking about. Whereas when it's continuous, it's yeah.
Maybe another way to say that is for backprop, or for all of this stuff, really your variables, your function has to be differentiable. And what does that mean for discrete variables?
Well, first of all, we have to distinguish in discrete variables, you still have continuous weights. So what you're adjusting these continuous weights, but also, you know, in terms of inputs, discrete versus continuous, I think backprop is, you know, theoretically the chain rule, but in reality, it's a difference quotient. So backprop and difference quotient, I mean, it still works for discrete inputs. It's a difference quotient now.
But discrete suggests finite. Is that correct? Would you agree with that?
Discrete suggests what?
That discrete values are finite. Whereas if
Finite.
we're changing,
Yes,
yeah.
yes.
Okay, so and if we're changing those values, then so for instance, when we're initializing our model and we initialize our weights and we sample from a uniform or normal or whatever distribution, then they're potentially infinite. So,
Yeah, the weights, yeah.
Yeah. So then if where does the discrete versus continuous data insert itself? Because what I'm thinking is that those values, if the weights are continuous, where are the okay, I think I understand now. So we said the discrete values are the training instances. But is that what you're saying? That as a result that's what's changing?
The discrete is the input.
Yeah, the input, right. Okay,
Yeah.
okay. Yeah, I think, okay.
Okay.
Apologies, I may have confused things there. Okay.
All right, good.
Yeah, I wonder if also, you know, we should refer back to our top-down learning thing, and maybe there's some stuff here that we need to, you know, learn how to do, but not necessarily fully understand. I don't know. You know, some of this stuff, a lot of this stuff, you know, seems like, well, there's a lot of the details here that I haven't quite got a very strong intuition around, and maybe they're coming. Maybe we should ask our Oracle David if is it coming? Do we get the answers to all these questions, David?
Once again, I think I missed some of the intuitions. The thing that I was tied up with and spent most of my time on was learning that. So the insight I got from the later lessons was that what you learn in lesson 1 is what you should always try and do. So if you can reorganize your data in such a way that it easily fits into the standard models, you're going to have a much easier time of it. So he makes a comment at one point about building your own data loaders and making very, very complex data loaders. And he said that's basically a waste of time. What you should try and do is just use pandas and all the other tools to essentially restructure your data so that it is compatible with existing architectures. And then you can use transfer learning, and you can just layer your particular data set on top of that and get all the benefits that we see in lesson 1. So that's really the big insight I gained going forward. And so I focused my efforts around that. I really didn't focus my efforts around the deep intuitions on the actual meaning of the various different things in the layers. And it's very interesting that I completely missed that. And I felt I was making progress, and yet there's a big blind spot I wasn't even aware of. So that's actually a big insight to me. So I think I need to go back and do more reading around multi-layer perceptrons and other things, because I understand the difference between the linear and the non-linear layers and ReLUs and all that kind of stuff, but I just don't have this intuition that others seem to have around this, and so I'd like to fill that in. So any pointers on that from would be much appreciated.
I think, you know, because this is like a practical course, he does gloss over a lot of this stuff. For example, the most important thing is being backpropagation. I think if you, Andrew Ng's, his course Era has like a 5-minute lecture on backpropagation where he actually goes through the calculations of these weights, and that's where I found out they're actually difference quotients. The derivatives are implemented as difference quotients. So I think if you look at Andrew Ng's course Era, one of those, I'm sorry, he has like a series of five courses, but one of them talks about backpropagation where he goes through the calculations. I think that's really helpful.
Do you happen to recall if you're referring to the older machine learning course or the newer deep learning one?
I think the newer one, the one with like 4 or 5 courses in a series, but there's just one lecture. When I find it, I'll post it, that one lecture.
Okay.
Yeah, Lex Friedman from MIT and his course on autonomous vehicles also goes into a lot of detail on backprop, and I found it quite intuitive as well. He describes it in the context of a computational graph, and yeah, very good slides went along with that. So I'll try and dig that out.
Those I think I've seen on YouTube.
Oh, you've seen it, Sam? Okay.
I haven't watched them. I've noticed them on YouTube, and I've kind of mentally took note of them. He has some interesting guests speaking in those lectures.
Yeah, so it's actually the course prior to that one. I know. Yeah,
oh, okay.
I think he's running an interview type session course, I think, right now, or it
Okay.
will be finished at this stage. But there's an autonomous vehicles course that they're sharing online by YouTube there also, and I think it's lecture 4 or 5 where he talks about the backprop algorithm.
So this one is a pretty fast one. It's about 3 hours, and you can at least get a good overview.
Great.
There's also a YouTube video from a talk. I think the name of the guy is Martin Görner. It's when you search for TensorFlow without a PhD, then you will find that talk. He's explained that pretty good.
Interesting. Good.
Oh, that was Jeremy's the picture Jeremy used, right? From Gradient Descent.
Here.
5.
This one.
Yeah, Jeremy had that picture too, right?
At least one that's similar. I don't know if it was this one exactly.
I think everyone's using the same, even Andrew and G.
Yeah.
All right. All right. How far well, before that, what about the folks who haven't chimed in yet? Where are you in your journey and explanation of this stuff? Anyone want to chime in either via voice or the chat?
Yeah, for me, was pretty much the same. I was struggling a bit with pandas and stuff. I tried to use that knowledge for the Kaggle competition that was running, was closed recently. That was on the Avito, so it's like Russian eBay, I guess. Prediction of whether the item would be sold. It's quite complex because it had this tabular data, but also it had pictures. So each advertisement had a link to a picture, and also it had a description of a picture. So you could combine like the image kind of, you could extract, but I just wanted to use the kind of tabular data, but yeah, I just entered the competition too late. I was struggling with pandas and all that stuff. Yeah, but similar.
Chuck says he's behind the week.
Sam, can you hear me?
Yes.
Okay, I think
We could hear you, but then you muted yourself, I think. That was Mahesh?
yes. Can you hear me
Okay.
now?
Yes.
I think the first point that you mentioned as regards the intuition for categorical versus continuous. Okay. I think to me, the most important part in this lesson was really the concept of these entity embeddings. Okay. Because they are very, very intuitive as far as the way I look at it. So first of all, I'll try and put it in basics. I mean, all neural networks really work only with numbers, right? It's all matrix multiplication. Because let's say when we talk of back propagation, or we talk of, let's say, the forward propagation also, you only have a series of numbers which are going forward and coming back. We could call it the weights or whatever. Now, continuous variables are those where where in the actual data, let's say we have a number which could be an integer, it could be a floating point. For instance, the sales data, the temperature data, the mileage reading data, these are all actual numbers. So wherever I see a number in the data, that is continuous, okay? Wherever I see a number which is not a natural number, for instance, in the Rossmann example, there is a store ID. Now a store is a physical entity in the real world, right? Only for the sake of the database, they have given it an ID. Similarly, you could have a product where only for the sake of the database, they have given it an ID. But a product or a store is actually an entity in the real world, right? So one way of looking at categorical is look at the word itself, categorical. It means that there are categories. That means there are categories of stores, there are categories of products, okay? A special example as regards categorical, where there's a lot of confusion, I think, is as far as the dates are concerned, right? Now, when we look at a date, let's take today's date. Today's date is 30th June 2018. Now, I can put it as an integer number, I can put it as a DDMMYY or whatever. But when I talk to a person, the meaning of 30th June 2018 carries a lot of significance. So I think one of the points which I think Jeremy has mentioned, and which is also what I caught up in the readings, is that when we look at dates, when we look at dates as a categorical variable, I think Fast.ai itself gives you a lot of not Fast.ai, sorry, Pandas gives you a lot of functions that you can get. Let's say date of the week, is it the last date of the month, and so on, right? So I think one issue which needs to be clarified is what is categorical, what is continuous. Okay. Now coming back to the entity embeddings part, I think that was the most interesting concept, because if you see in the competition, in the Rossmann competition which was mentioned, the third place was won by a team which had got zero domain knowledge. I think even the Rachel's post that you mentioned, she said the first two teams, I think Jeremy also mentioned that, the first two teams were people who had spent years in developing optimization software for the retail sector. But the third team is the team which used actually entity embeddings. Now that was a team which had zero knowledge as far as the retail sector is concerned, which really means that today, even if you do not have domain knowledge, if you use entity embeddings, you are in a position to try and get a better solution than somebody who has spent many years in that getting the domain knowledge.
Yeah,
Now, what is, yeah, sorry.
I found that very interesting too, because I thought that for structured data, deep learning is not really a thing. And apparently, just like in other fields like image recognition, which was really very domain specific, you had to have very big knowledge of how to process images and stuff like that. And nowadays you can really just throw a convolutional network in it and get world-class out of it. And that's maybe becoming a thing for structured data too.
Yes, yes. In fact, when you talk to people in the industry and you tell them this, they do not believe you at all, because everybody thinks, I'm working in this sector and I've got, let's say, 30 years of experience. How do you as a software person come and tell me that my experience doesn't really have value? But fortunately or unfortunately, this particular lecture, this particular entity embeddings proves that. Now, what is the intuition behind entity embeddings? See, essentially every entity, whether it's a store or a product, has got certain behaviors in the real world. For instance, a store may be open or a store may be closed. Now that's a type of a store. Again, a store may be, maybe a large store or a small store. Again, that is a type of a store. A store may be, located in downtown or located uptown. It's a type of a store. A store may be, a store may be, let's say, in a mall or not in a mall, standalone. So these are all behaviors of that particular entity, and which does not get reflected in that store ID. So what entity embedding tries to do is it tries to say, okay, fine. The store, what I'm looking at, the store ID, what I'm looking at is not really just a number. It represents a lot of meanings from its attributes in the real world. So essentially what an entity embedding does is it converts that single store ID into a vector, which is, and for each of these vectors, for instance, if you see in the example that he has used, I don't know whether it's lecture 4 or lecture 5, he talks about movie ID and let's say user ID. So certain movie IDs could be, whether it's a high-tech movie or a non-high-tech movie, whether the movie has got special effects or not special effects. So essentially what in entity embeddings, the intuition is that we are taking an entity from the real world, we are converting it into a let's say a matrix of into a row vector, and each of the values which are there represent different behavioral aspects of that entity. And what really happens is that, through the process of I think Jeremy has shown, even in Excel, if you use the solver equation in Excel, you are able to arrive at an entity embedding which is reflecting in the training data. It reflects the entity embeddings which can be used ahead. I think it's a very, very fundamental, and it's a very, very important discovery, and probably a lot more research needs to go into it. I found it very, very interesting and very, very useful, because every organization today you go and talk to, they have these entity embeddings, but these are entity embeddings are either, in the minds of like, you talk to any experienced salesperson, he will immediately tell you, which customers are good, which customers are not good. But let's say beyond categorizing that customer as good or not good, in his or her mind, they are making a decision of probably hundreds of variables in their mind. The customer has got money, he doesn't have money. The customer is interested, not interested. These are different behaviors which essentially mathematically they get represented as entity embeddings. I don't know whether I could be more clearer, or
No,
does that
that's good.
provide insight?
No, that's great.
I agree.
Yeah,
That's
just
good. Good.
there is for the Rotsman competition, the guys that got third place, they published paper on it. So I'm just going to. I didn't read that before. They published that on archive, so they explain, I think, quite nicely there on what they did and why they did that. So maybe might be worth to read. Yeah, that's the one.
Yeah.
Yeah, it's
Yeah, I read that paper. It's a very complicated, explanation, to be very honest with you. I mean, we need much more simpler explanations which are easier for for people to understand. That's my opinion.
okay. I didn't read that. Okay.
So catching up on the chat, some folks were chiming in on kind of where they are. Carl, haven't been able to get started as Jupyter seems to be unable to import Fast.ai. Carl, is that started at all or started for this lesson or what? Haven't been able to start lesson 1. Oh no, there is a doc that is in the Slack that Siren put together that you may find interesting. So it's kind of like a FAQ for the study group and captures a lot of the links that have been shared. But on this first page, there are links to, basically a ton of different ways to get started with, to get your environment set up. I think, so this is several links about Google Colab. This is also Colab, Windows, Paperspace, Docker. Did we get yours in here, Kai? Is one of these yours?
I think it's the Docker. Yet another
It's
Docker.
this. It's on you posted it to Fast.ai forums.
Yes.
Okay, got it. So Kai's Docker is here. I use this one to get set up on Google Cloud. So hopefully, with one of these, you can get set up in an environment somewhere using Windows. So maybe try this one if you haven't seen it yet. Fast.ai on Windows.
Sam, can I make one more point?
Sure, please.
What has been revealing to me is that as I've been going through the lectures, in almost every example which Jeremy says, he's looking at, what he's saying is that you have either results which are, better than world class or near world class.
Mm-hmm.
I think this video series was done in November 2017, which was almost 9 months back. I think the first course. So to me, what I would suggest to folks is, what he's really showing over here is, the way I look at it is it's extremely powerful. This is not something, which is easily accessible to, let's say, people who are not working for the Googles or the Microsofts or the Facebooks. But the problem is, as we have discussed earlier, is the top-down approach really may not be the ideal methodology to go about it. So what we should probably try and do it, revisit the videos again and again, look at all the links which he has shared, and try and get understanding from those. Because even if I'm able to use this library, the Fast.ai library, and I'm able to demonstrate it to someone that I'm giving you a world-class result, that itself is an achievement, because it's not, I need not understand the library, but even if I can, let's say, create data and I can present it to a customer saying that this is what the library can do for you, I think it's an achievement. So one should not give up is what I would suggest.
And also, I would encourage people to not give up. I started with data science stuff like 3 years ago, and the first things I did were also some Kaggle competitions. And really, at the first few times, I did not know what I do, and it's getting better and better when you just repeat and repeat and read more and more. Then you'll get better and better. Yeah, it's like for any other thing too.
Yeah, one thing that strikes me every time I work on this class is that, as awesome as the Fast.ai library is, like, it's also horrible in a lot of ways, in particular, like the variable names. And I had joked here about, wondering if Jeremy was a pro programmer, and someone posted in the forum, Surin posted that apparently he was like chair of the Perl 6, so he's a big Perl guy, and it shows. Like, almost, if I had the skill and the time, I'd want to do like Fast.ai on training wheels or something with actually like understandable variable names and parameter names and stuff like that. It does not make it easy, especially considering, that's part of what they're trying to do with this. But it's also, you know, if you ever heard Jeremy talk about deep learning, like he, you know, what I think he is really kind of excited about this idea that like deep learning is a game changer and can be applied to all of these different areas, even areas that we think it can't be applied to. It's just a yet issue. We haven't figured out exactly how to apply them to them. And so, you know, this idea of applying it to time series data and categorical, you know, variables and things like that. This is all stuff that we didn't know that we'd be able to do. And to Mahesh's point, the fact that you can do this and achieve, you know, near world-class results without having deep domain data, you know, it's a game changer. It's totally new. And I think that's the reason to kind of, you know, stick with it, even though it, you know, it's not without its bludgeons.
So I'm just adding to your point. You know, I mentioned that this course was done in November 2017, but if you just Google Stanford Dawn, you know, Stanford has a group which has recently in April 2018, end April 2018, they have come out with results on end-to-end, you know, machine learning. So over there, if you see, the top results have been given by Jeremy Howard's Fast.ai students. So and this is just as new as April 2018 and 18. So I think he and his team are moving really very fast. Yeah, the last link, the Dawn bench, yes. Now
Nice.
look at the results of you know, look at the results and where and look at the people against whom he's competing. You know, you have Googles and you've got world-class teams over there, and he's got student teams who are actually beating the benchmark. So I think it's remarkable.
Yeah.
I mean,
Yeah,
Jeremy himself was a leader at Kaggle for some time, so he was the ranks there.
Yeah, this was an interesting announcement from back in April. You know, what was I thought there was one that was even more dramatic in terms of it's this training time one. You know, prior to April when they were doing this, the training time, you know, in January, the training time to 94% accuracy for the CFAR data set was an hour. And then in April went down to 35 minutes. Then their first, you know, dramatic result got it down to 6 minutes. And then ultimately by also in April, cut that in half to 3 minutes. It was pretty impressive. And that correlates to the cost to train the CFAR model also. It's pretty cool stuff.
There's a blog post on that stuff on the Fast.ai site.
Oh, really? Okay.
Yeah.
It's interesting that I was looking at a course that Peter Abeel's running down in Berkeley. I'm not going to go to it, but one of the things, they call it taking machine learning into industry or whatever. And they're now citing Fast.ai at Berkeley, which I thought was pretty amazing considering they're such leaders in the field. So.
Did that start yet? I remember him, like he put up like a express your interest page. Have they put up any more details on that?
No, I immediately registered. I may still try and go because I'm very interested in the work that they're doing. It's related to my project. But
and is it a physical class or a online thing?
It's a physical thing. I think they want to. I think they want to go out and meet the people who are actually doing the do and try and understand better how people are using it and what they're using it for and what they're trying to do with it. They haven't lost touch, but their work is very challenging to really grapple with. I think they're trying to build bridges to their own work. They see the success of Fast.ai in its ability to, you know, really have an impact. And I think that they're looking to try and get their work on deep reinforcement learning to have some of the same kind of impact on the industry, because it's exceedingly difficult to work with the deep RL stuff. I've actually had some success, but it was very challenging.
So getting caught up on the chat here. Estevez, new to the topics, slowly trying to catch up. John, chunk of time on Pandas, working through the notebooks. Kazakhs, can dependent variable be categorical? Can the dependent variable be categorical? In this case, it was sales. Well, categorical dependent variable is like the output. So that would be like the MNIST competition. So you're just putting you're just putting a layer at the end that's choosing something.
Yes, Sam,
right?
I think, yes, it can be categorical. For instance, it will become a classification problem.
Right.
You know, whether an event is happening, not happening is a classification. I mean, it's a, so to answer that, I think it can.
Yeah. Yeah. The MNIST data set or MNIST problem is a classic example of this, where at the end you're choosing 0 through 9 as your output digit. Not had a chance to work on implementing lesson 4 learnings. Most interesting so far. A couple of links here. Intro to backprop. Oh, this is the, which one was this? This is the Lex Friedman one. Okay, cool. That's 6 minutes.
A link related to that was added also by Sebastian. Maybe they look quite similar, the lectures.
All right. Jeremy's TED Talk, presumably on kind of deep learning and the power of it.
Yeah, it's pretty good. I've read that one. It's pretty light. It's not that heavy.
Okay. Fast is help from SageMaker, how Fast.ai can be used on their platform. Oh, well, I was just wondering about this yesterday, I think. They just announced support for PyTorch, I think. All right. AWS just recently announced support for PyTorch, and I was wondering how long it would be before someone got the Fast.ai library figured out, set up on there. SageMaker is similar to Colab, I guess, or provides a Jupyter notebook type of experience. And another link.
I was going to say, I looked at the pricing on SageMaker. It looked like it was more expensive to run GPU instance, on a GPU instance there than some of the other platforms.
Oh, really? Yeah, I haven't looked at that, so that's good to know. So question for everyone, given where folks are and kind of the shift that happened in around lesson 4, does this pace still feel right for folks, or do we want to slow things down, take a little bit, maybe go to 2 weeks per lesson or something like, as an example, we talked quite a bit about Rossman, but didn't get into the NLP part of lesson 4 at all. How do folks feel about the pace?
No, I think the pace is very, very fast. It's unreasonable to expect people to learn so fast. And as was mentioned in the first lecture, Jeremy expects people to go back to lecture 1 and keep doing their own research. So I think it will take time for the concepts to sink in. That's what, if you really want to learn,
Yeah, like for example, I just looked at the the structured data. So in lesson 6, there is more in-depth look into that problem. So I paste the link that as well. So they're going to revisit that topic, lesson 6, and also they will go through that paper. So this is kind of the top-down, I guess, thing. So they kind of show you what you can do, and then later, lesson 6, he will explain more how this works, I guess. So yeah.
Yeah, I think 2 weeks per lesson is good.
And do you think we should have 2 videos within those 2 weeks, or spread out the
Yeah, I would
series
think
of
we
the
would
work?
continue to meet up weekly and chat about this stuff, share what we've learned.
So you think that 10 hours per week is not enough, as we were kind of thinking, or we don't have time to put 10 hours a week? Is that the reason to kind of have once every 2 weeks?
I'm asking the question, really. I think it probably varies for different people. For me, it is a challenge finding the 10 hours and keeping up with everything. And but for other folks, it may be just wanting to go deeper into the material and some of the background reading.
Yeah, it's fair enough.
I think you can pretty much self-pace. I mean, if you do fall behind or get ahead, it's not the end of the world. But we're recording these, the insights are there, and the forums are active. So go at a pace that you can sustain. I think that's the right way of thinking about it.
Mm-hmm.
I'm trying to accelerate through it. I'm not saying I'm going at 4 times the speed, but I'm putting the more hours in. So I'm able to kind of get ahead a little bit, but I still get great value out of these group meetings and everything. So yeah.
All right, so I'll maybe put a poll up in the forum and try to get a sense for how folks want to play it. It also strikes me that we tend to have about 25, 30 people maybe on this, and some 400 or so people have said that they want to do this. So we should figure out what's going on with them, and if there's ways that we can, help them get started as well. Thanks everyone for jumping on. This was a great session. Tons of interesting discussion and resources shared, and as per usual, I'll get these notes posted up and we'll get the video up in a couple of days. Thanks everyone for contributing.
Thanks, Sam. Thanks.
Thank you.
Sam,
Thank you.
on the just 1 sec, Sam. Sorry.
Yep.
I just wanted to. Do you want to contact and chat about the August paper?
Yeah, sure.
Or I can just post in Slack, I guess. There's a couple of different options. I was wondering if we should run a poll on that as well, but I think I'll just pick the paper I have an interest. So I'll just send you a link in Slack. It's fine.
Okay.
All right.
Awesome.
Cheers, everyone.
Thanks,
Bye.
David.
Bye.
Bye.
Bye, everyone.
All right. Thanks, Kai. Mahesh.
Have a good day, everyone.
Bye-bye.
Bye.